So I think yesterday we have started to work on simple linear regression, and even we have started the life cycle of machine learning projects and algorithms. So I think today's session is the most important session for machine learning. So once you get this one, definitely in coming sessions also you will use this kind of tricks and techniques for implementation of algorithms. Means other algorithms are. I think I know many of the questions you will get today, but don't worry about it. I will give you every question's answer. If suppose I am having any question, if I am getting any problem to explain you, then definitely I will take a time and I will tell about all the things. But this is top. These are the topics that I'm going to tell you. These are most important topics. Okay. So let's go for implementation and explanation. Before I going forward, I will explain the basic part that yesterday we have covered. I think almost all the people that we were in last session attended the last session, right? See this one. So let's go for explanation, and definitely you will enjoy. Let's just in the second connect this one. Mhm. So what is the first step that we have done? That importing a libraries, right? And the point is that if I'm telling you about importing the libraries and these are the things, can I ask you one question? Your it's important, right? I think it's visible. Okay. So what is the independent variable and dependent variable? What is independent variable and dependent variable? Anyone? Uh, some of the points that we have, all other independent also. So what is the reason? I'm just asking you all why we have to why we have to slice down our data set into training set and testing set. Any idea? Any idea about it? Why we have to slice down our data into training set and testing set? work on the data and apply the algorithm for the teaching of ML. Yeah, that's correct actually. The work of data. So see, it's we have to train our ML model. That's the correct thing. But what is the major work? There we are dividing our data into training set and testing set, right? So why to take testing set instead of going for the custom testing data set? We are not taking any kind of observational points that our side. We are dividing our whole 100% data into the suppose 80 to 20%. So we are doing no to 20%. We are creating our testing means 20% of data. So what is the use? Why not we go for the observational part that comes from the our side to check accuracy of data? Okay, that's correct actually. To check the accuracy of data. Another one, we will train on the set, do the test on the other model to see our algorithms work. Yes, to get analysis on particular dependent variable to rate the dependent variable from the other independent. Okay, see, the major thing about machine learning, we can believe on our own data set. No, means whatever the data set you are passing to the model, that is the key point. Means that is the evidence you have only. If suppose if you are creating yourself only data set, means you have trained your data set, whatever the data set. I'm just measuring one thing here. Wait, I will tell you. Own data set. Own data set is nothing but it's your custom data. Custom, you have created your own data kind of things. Okay, and here we have actual data. Actual data is nothing but your dedicated, suppose credit card fraud detection, that banking concept, banking HDFC Bank is there, and the HDFC Bank is sharing the actual credit card data. That is an actual data. So actual data is an actual transactional data. So if you divide your data set, you have the evidence, actual evidence that already that transaction, see what I'm saying, already that transaction we know about, that transaction is true or false. Already we know. If suppose if you create your own data, if you create your own custom test file, then what is the problem? Even you don't know that your transactional value is incorrect or not. Even you don't know. Only you have customized level you have created. This transaction is true. This transaction is false. For checking the accuracy, you have to have, yeah, you have to pass your own actual data. You have to slice down the data and pass it down into the into accuracy score. So accuracy score is into secondary part, but why to create accuracy? For checking, why to pass the actual data, why to pass a testing file to check, is it our algorithm in the good, is it algorithm is going into the good direction or not? We have to check every factor. That's why we are dividing our training set and testing set. Now I'm asking to you another one question. Is that we are getting any kind of data imbalancing problem in regression? See what I'm saying is that possible there we can get a imbalancing problem into data set. Are you getting my point, guys? Do you know the imbalancing means? What is the imbalancing means? I think that we have discussed previously also in the classification, because how much the imbalancing concept matters, that we are going to discuss here. We have to choose a random state is equal to 1, then it should be fine. See, random state is gives you to pick up a data randomly into training set and testing set. Only that is the work. But that is an impactful. If you pass 100, 500, 510, definitely your sequential order will be changed into the training set and testing set, right? It is wise to train the ML with the ideal custom data and test it into the actual data. See, if suppose if you are thinking about custom data, that is that you have to believe in your custom data, means you have to think about my custom data is incorrect. Is it correct? No. If suppose I'm just giving you best example. If you draw a any person's face, 100 people's face, and clicking the pictures, and your actual person's face and drawing pictures are different. No, drawing pictures, sketches are different, and photographs are different. If you pass the photographs, you are believing that that is an actual photographs, that actual images. But if you are drawing, if you are making the sketches, that is a custom part. If suppose your ML algorithm is learning that custom part, even you will not believe on your algorithm if suppose he says yes or no. I think you got the point. So let's go forward. Any question that remaining yesterday's point if you are not getting? Importing the library. Second, load the data set. Third, we are entering into the loading the data set and slice down the data set into the X here, this one, data slicing, right? Data slicing. And the third part data slicing, and fourth part is here we entered into where divide the data set into training set and testing set. Actually, I have to create a new file, but don't worry. Till now we are working. We should have to work on the same file, but it's okay. I'll share the same file in Saturday and Sunday, so you will get to know. Yes, we'll change the base size as well. I'll take here 0.2, so you go for the testing. Very taking some time, right? We have started a training and testing and splitting here. And once we cover up, check out the sizes. Even we have discussed about sizes as well. So check out the 24, 6, and what? 24, 6. So that is an training set and testing set point, right? So let's go for implementation of simple linear regression that will be useful to you, right? Let's go on. So now I'm passing algorithm. Which algorithm? A simple linear regression algorithm. Okay. From from the scalar dot linear. See what I'm passing. Linear model. What I'm passing? Linear model. Import. What I have to pass? What I have to pass? Linear regression. Okay. from sklearn dot linear model import linear regression. So once I got this one, check out what I have to use. See, this is a library. Linear model is in package. Linear regression is in my class. That is my algorithm. Okay, and that linear regression algorithm is stored into where we that get in sklearn. And this kind of questions definitely will get into interview. Means what is sklearn? Is it possible that we can, when we implement the sklearn, we get the linear regression or not? So that time you have to tell yes. There we have the linear model, and you will get an easily that linear regression. Okay. Now let's move forward here. Let's move forward. Now we have to create. I will tell you the whole process. First, we will go for the implementation, and then we'll discuss both. Now, linear regression. I'll create a one object of linear regression, R1. And once I create an object, you have to pass your class here. That is your algorithm. That's it. Like you are creating a object of a class. And you know what? The code is not visible. It's visible, no? Check out, sir. If suppose, wait, I will do one thing here. Now, 1 second, check out. See, R1. Okay. Once I create an object, you have to do one thing here. That is an R1. You have a no. You have to train your model. Now you are implementing a simple linear regression model. And that linear regression model, we are going to train that particular model. So how to train? So training, what are the values that you have for the training purpose? Which are the variables? Can anyone tell me? Can anyone? R1 dot fit extreme, and who is another? Y train. Yes, right. You cannot pass train test, means you cannot pass directly training value and testing value. See, you have to pass X train and Y train. So now question will get one thing here. Why to pass X train and Y train to train? Can anybody? Is it necessary? Always we have to pass X train, X test. If suppose if you pass X train, X test, then model only learn only features, X features. Even he don't know that, even he will not get that what is the answer of input features. So why to pass? Why to pass only X train? Why not I pass X Y train as well? So he will know that this is the transaction, this is the answer. Means he will learn, he is going to learn about a input feature as well as the prediction values. That's why we say that machine learning learns from the output and then go for the prediction. Learns from the output, go for the prediction. Learns from the output, go for the prediction. Are you getting my point? Okay. So let's go for the another one thing now. Um, if I'm giving X train and Y train to the model, see, is it possible? Is it possible that X train transactions are there? So which data set we have here? Which data set? Salary, right? So what we are going to predict here? What we are going to predict? This one data set is there. No? So wait, I will tell you. So many people they are getting this question to them about Okay, see, data set dot head. So data set dot head I'm saying. So he's showing year of experience and salary. Is it possible if suppose if I'm saying I have divided my data 80-20 and upper side of 80 is will goes into the X, lower size of 20 will goes into the testing, train and testing. Is it possible? This is kind of slicing will go there. The slicing will goes on the basis of your random state or not. Is it correct? Means you are not getting their sequential data, you are getting their random data. If suppose if I'm getting a random data there, then definitely your variations, when you change the random state, that time definitely your answers are changes. Sometime in the rare case your answer remains same, but it changes. Why? Because your observational point, if suppose if you are passing random state is equals to 5 and you have divided into the training set and testing set, next time when you pass, random state is equals to suppose 10 or 100, what will happen? That already that whatever the data set that goes into the training set, no, whatever the observational points that goes into the training set previously, if you change the random state with the 10, then definitely that observational part, that possibilities that leaves that training set and goes into a testing set. So maximum probability is that there is a not a fixed position of other observational points, any of the observational points, right? Then 80% predict will be there. No, actually what will happen, see, I will tell you, wait, I'll go for the execution here, go for the execution first. See, now the all the linear regression logic is present into where? All the linear regression logic present into the linear regression model. And that we have passed extremely fast wide. Even I never explained you the linear regression model. Only I'm implementing because machine learning gives us a predefined linear means any of the algorithm. So you need not to do any kind of mathematical equations. Linear regression algorithm itself, he can do the process. That's the one thing. That is a very rare case. The people are doing their own calculations. Those are having the maths good. But those peoples don't have a mathematical structure or any mathematical background. I will tell you guys, your machine learning way better than that people. Why? Because you will not directly enter into the mathematicals. You only believe on only functions, and that's the good thing. No, instead of getting headache on calculation, you can use your functions. And in the meantime, suppose if you go for the product development, that time definitely you will get a problem to explain your product, how you guys created this one. So if I executed, this is my actually fifth step. Sixth. Now, what I'm going to do, I'm taking one variable, y prediction, y prediction equals to R1. Who is R1? R1 is your model. R1 is kind of kid. R1 is kind of child. So he learned He learned X-train and Y-train data. Now he's going to give the answer when you ask any question. So Y prediction is equals to R1 dot what you have to pass. Predict. This is a predict method. And in that you are asking the questions. You can pass here X test. Now many questions will rise here. Why you have to pass X train? Why you have to use their function that predict? See, R1 is not understanding any other language. He understand only predictions. Means predict function is useful for get the data from the X test or your testing observations and pass it into the where R1. And whatever who is R1, R1 linear regression. R1 will pass the data into where linear regression model. Linear regression learns that whole problem statement and gives the output back to the Y prediction variable. So whenever I pass the Y prediction for the printing purpose, you will get some kind of actual answer. See, so now you guys are thinking about what is this. So before, see, I'm implementing here, I'm implementing and I'm telling you the life cycle because yesterday we have started that life cycle and now we are entering into the sixth step, right? And sixth step telling you the model prediction. Can you tell me who is an X test? Who is X test? Testing file, no. Am I right? This is a testing file. That's why you have divided that X training in testing set. Now the question rises, another one question. Rahul is asking, so what about Xtrain? Xtrain has done his work. Xtrain has done his whole process. What is the work of Xtrain? Xtrain is useful for the training the model only. Xtrain has a work of training the model only. You can ask the Xtrain data also, not an issue. But training purpose you have used, no? It's suppose if I go for another, if I go for the print extras. Yes, sure. That's the good point always. Wait, what happened here? Something is wrong or what? Just give me a second. Okay. Actually, I thought that is an salary. So this is an indexing. Now check out one more point here. I think, guys, definitely you will get some problem to the here. Check out. See, the actual data is nothing but 17 number. Check out 17 number index. The year of experience, the 5.3 years of experience. Your Y test is giving 83,088 rupees of salary. But your prediction says you have to have you 75,074. Wait, I will make some formatting properly. Then definitely we will get understood. Can display one to one method. Wait. One to one, we have to create the formatting like that. Hmm. Okay. So actual year is in exist. So that is comes under the 5.3 years of experience. And he actually means actually your data is saying that 83,088 is your salary. Second thing, if your actual model, your actual data is giving 83,000, your model is saying you have to give 75,000 almost. If suppose check out the 21 numbers of index. If you have a 7.1 years of experience, your actual salary that given by the company that is a 98,273. But your model is saying you should have to pay 91,873 rupees. So these are the nothing but prediction values. This is a prediction value and this is an actual value. This is an actual value. Means are you getting the difference between the actual value and prediction value? You got the point? What I'm saying? We have to pass here round up. I think we should check the real data, not a prediction value. And like, see, yes. Actually, what is the main point? The previously I already said, actual salary is and trustful. Your evidence you have. Test set is nothing but your evidence. No, already you have. So this is my X test data. X test and Y test are similar because 17th and 17th column see here. The 5.3 years of experience already your model is saying that 83,000 rupees of salary. But your prediction is saying what? Your prediction is saying you have to have give the how much salary? 75,000. Means what is the difference? How can you check the difference? There we have the 83,000 minus 75,000. Right? So this is the structural point. This is the structural point of your means I'm not telling you linear regression now. I'm telling you the life cycle here, how we are going to check out the any of the algorithm. Any algorithm, if I'm going to tell you, if I'm going to teach you, that time how do I go for every process that I'm telling you. Okay. Still not entering into the simple means logic of simple linear regression or something. Or I'm not telling you the actual work. How to calculate and display the confidence level. Confidence level means you are thinking about hypothesis or you are thinking about prediction line. Yes, sir. Yes, prediction line. So that is your whole. I will tell you the logic as well because still we haven't entered into the linear regression logic. But I will tell you because I'm just mentioning you the from yesterday we have started the life cycle means how we start the logic and how we ended up. That's the point. But I will go for the each and every points. Don't worry. The question now I'm getting how to calculate the display the confidence. Okay, no, actually not getting why so difference. Actually, see sir, your actual data prediction isn't different, and your model prediction isn't different. Definitely, you will get this kind of difference. Even sometimes this is a continuous data. This is a continuous data. You are getting how much difference? The 83,000 minus 75. How much? 8,000 difference you are getting. But you are satisfying. No, you are getting in some around some values. If suppose you go for the any kind of like a probability answer, this transaction is true or not. That time your actual transaction he is saying wrong. Directly suppose that time what can we do? The model isn't different model whatever the model learns no that much time that is the thing he will go for the means answering and execution. We did with the test size point 2 have a look for changing what is the difference. Yes, we can go. See, check out first structural point. For understanding purpose, you have to just pass it down here. One comment: the year of experience this much, and salary is this much, and actual this much. Okay, so let's go for changes. See now, we have changed with the 30%. It is correct. We have changed with the 30%, and after 5.3 years of experience, 83,000, and you are having this much. $74,821. I think definitely you will get a difference here. Why? Because you have changed your training. Training data set is changed. No, your training data set is changed. If you are passing 0.3%, then 30%, 70% he is learning and 30% will do the testing purpose. We can pass a single value as well. I will tell you that how can we pass the year of experience and we will get the answer. But here, what is the major thing? First, you have to learn about testing size, training size, right? And about random state. How can we pass the random state and all? What about if we change the size of 0.1? Yeah, you can pass, but definitely you will change. You will get a change into the. See, you are getting changes. First 75,000, 74, then 75,389. So what do you think? Means how can you think about my model is saying correct? Can you? What are the possibilities that you are thinking about my model is incorrect? See, now the first thing, your model should have the proper data set. Means here we have the only data points, no, only 30 data points, right? You have to, is that possibilities that you are believing on your data set? That means this much kind of low count of data we have there. So now which one we believe is fine? This could be a problematic if we predicting the company's financial. See, you are a data analyst, you are a machine learning engineer. You only give the assumptions. You cannot give the 100% surety that your financial problem will go up. Are you getting my point? You only give the assumptions. Means if suppose if suppose your data set is going into the downside only, means your financial, means your profit always goes into the downside, then you have a right to tell that in the coming 5 years definitely your profit will go down. Only assumptions. Why? Because go down because my model is saying your profit will come down. It up to that person, he is going to believe on your data and your model or not. Because it's not necessary that always goes with the only one prediction. You have to create near about at least 7 to 8 prediction points that you can believe, because your model is giving into the downside or upside. If your model is always goes into the, means if you are changing the test size and model goes into the downside, no, you can say that no, your financial profit will goes into the downside, your profit will goes into the upside. Is it correct now what I'm telling to you? Right, okay, that's what I wanted to know. We give the predictions, not actual values. See, we give the prediction. Actual values to model what I, Rahul, is for the prediction purpose or training purpose. For the prediction, see, for the checking the accuracy, because you have the only one option that you have to believe on your actual data, means your X test, because uh, that is your actual data points that you got, that you can believe. But if you created your own custom data set, that you, how can you believe on it, right? How can you believe? uh, so I think you have shared any the question that df is equals to pd or data frame print df difference. Yes, I will try. This is your finding the error, means yes, positive error. That is, we are going to enter. Shape past division one, x test, y test, y prediction, y prediction. Mhm. See, difference, yeah, if you want to calculate the difference, you cannot do like this. How can you do? It will not pass because that is in, sir, that is in. How can it possible? Okay, wait. You have done one thing. You got the point. What is the problem? This is a dictionary. Remove the difference first. Actually, if so, this is a key value pairs, no? And this is a list. So list, this is also list. This is also list. This is array list, no? It will not work actually. Okay, I will try this one. No. Shape past 1, 3 and indices. Actually, something is wrong here. I got to your point that you want to know the difference between that. there should be a way to display these values in three columns. Yeah, actually we can use for the reshape concept as well, but I'm just thinking about some different ways. But I will tell you one more thing. For example, we have to have passed their axis one maybe. X test, Y test, Y prediction should have the same shape. Right, exactly. Yes. That's why that problem we are getting. Y pred having same, both are same, means three of them same, not an issue. Then also we are getting problem. Wait, we'll do one thing. I will try this is the last time and definitely. Data is equals to um, if suppose if I choose here different form fully dot on, yeah, to the criteria. X test, Y test, Y prediction. Concatenation should have to work on. This is mm, sir, just a minute, Ivan. I'll do one thing here. Data is equals to PD dot. The same code I'm just want to use data. Okay, but I'll choose this one. This is X test data. X test. Right, and then I will go for this. This is same concept. So just I have changed one formatting here. Mm, prediction value. Prediction values. Hmm. That is the thing that is going on here. That formation is like this. That's why. If suppose if I do this one, done. Actually, the x-axis has a 3 of 1, no shape. So actual salary and prediction values are having the -1 we have passed there. So only one column getting by the indexes for this, right? So this is our actual salary and this is the prediction value. So this will work. Are you getting everyone? You got the point what is going on here? Please put it in chat. Yes, sir. Take it. Got it. Hmm. Yes, sir. I think use the way you said no extest dot ilog 0. The way. Can you sir pass the code the way I have passed no code? Please edit it. Zion sir. Extest dot ilog you have the same you did no. Please pass this. Create any code like that one. The way I have passed this code and edit it and share it to me so that I can get it directly there. Right. So you guys are thinking about how much 3 rows we are getting. So data set columns. Why you are getting 3? Only because your testing size is in 0.3%. So that's why. 0.1%, sorry. That's why. 30 is 10%, that is in 3 only. So if you change, then definitely it will change. I think it's possible from your side. You got the point what is going on here? Are you getting points? Actually, see the way we are going to implement no, the always some facts matters. If staff would be happy for a pay cut, this model would save millions to the company. Yeah, that's correct. That's correct. Which which of the company, which are that companies staffs or any employees do they used to or they would like think they would like to go for this kind of model. Company get an benefits with this model, but employee will not get any benefits with this model. Employee will reduce their salary. How? amount by this model, because these are the machine learning tells you the how much salary you are getting. If suppose on the basis of knowledge that company is thinking about you, then definitely they will pay you a lot of money. But on the basis of model, they are thinking model how the model will go for the uh, understanding your behavioral part, understanding your uh, knowledge. Only paper work out. It's kind of, the evidence you have in the on the paper, then only we can believe like that the process is here. If you have good data, then only I can. If you don't have good data, then he is not going to believe on you. Even he will give you a wrong direction if your data is in wrong. Means what is the best thing in the machine learning, that if your data analysis is good, then your machine learning is good. If your data analysis is bad, you cannot do anything in the machine learning. What if your means the every algorithm, the life cycle of machine learning, everything and you are passing a wrong data, and even so many people are like that. We have in your some of my batches are there actually. They know the artificial neural network because when they join the company, that company thoughts like this employees are good in the coding. Why not we put into the artificial neural network? And they what they are doing, they are taking the directly data sets and passing into the artificial neural networks and CNN more. So company thoughts like that our employees are good because they are working on the artificial neural network and our AI department isn't good. But you know what? Sometimes your client wants to change some possibilities of your output. That time your employees also don't know that how can we change the formats in the data set, how can we make the changes in your data points. That time definitely you will get in some queries in analytical process, data pre-processing, data cleaning and all. And then you are going to learn about once again where data pre-processing, numpy, pandas and all. I have I have some this kind of peoples in my batch. They know everything. They know everything about CNN, face detection, image processing, everything they know. But they don't know data analysis. That's why they are connecting once again in my session. Question not related, but upload on the portal. Live sessions are until 20. What are we doing after that in a actually, even what I never seen this kind of information. Even I never noticed. But definitely I will discuss with the administrator. We can go for that. No? Till then we can solve so many problems. But don't worry. So I think, see, now I would like to discuss about positive error and negative error. See, the way we have entered into the prediction point, how many steps that we have covered here? About 6 steps. Model prediction. The last step, that is an accuracy score. See what I'm saying? The word, see what I'm saying? Accuracy score. Is it necessary to go for the accuracy score? Hmm? Can anyone? How can we check a regression model accuracy score? Let's do another example with the big data set. Yeah, I actually I'm thinking about multiple linear regression because see, very rare case we can go for the simple linear regression. So in my thought, why not we go for the multiple linear regression? Even I will tell you that multiple linear regression. So there is an so many low examples, means minimum examples we get into simple linear regression, because simple linear regression has an one dependent variable and one independent variable. And when we go for what? Multiple linear regression. Then there we have one multiple independent variables, single independent variable. I hope more examples will clear all the confusions. Yes, sir. Don't worry. Every confusion will solve here. Why to go for without solving the confusion in second point, right? So let's go for this one. Let's go for it. So guys, what we are thinking about here, um, the regression point is there, right? Regression is in continuous data. Continuous, see, the way whatever the things that I am teaching you now, telling you that is in performance matrix. What I'm telling to you, performance matrix. Performance matrix is nothing but it is a part of your algorithm to check accuracy of model. So many people are thinking, what is a model? What is algorithm? What is the difference between that? See, algorithm is a single, but models are big. Means models are multiple. Are you getting my point? What I'm telling to you? Algorithm isn't same. Algorithm isn't single, but models are multiple. The way you have sliced down, 30%, 0.3%, 0.2%, 0.1%. These are the models you are creating. So every time your testing set is different, training set is different, your prediction values are different. So you can tell your client that, see, this is one model, means one algorithm gives you the multiple predictions with the multiple data sets, multiple models. If your random state is changed, your model is changed. Why? Because your output is also changed. Are you getting my point? Are we going to correct in the current sample in order to y value and predict value? Question is correct, not an issue. Correct. Samples in order y value and prediction value. See, there we have some means some possibilities that we can go for each and every stages. Means, see, means how many ways that we can correct and we can decrease the gap between the y and y means values. Are you getting the point? Means the way I'm trying to tell you how many ways that we have solving the things. Actually, the first way that we can think about, we can discuss with the client. First possibilities, we can discuss with the client and ask to the, these are the data points are correct or not, because your accuracy means your prediction values are getting different the way you have actual data. The first possibility. Second possibility is that you can change the test size and random state as well. This is the second possibility, because say, how can you believe your model is saying correct? Can you give me the answer? Means how can you say whatever the answer we are getting from the model, whatever the prediction we are getting from the model, what is the possibilities that your answer isn't similar, little bit similar to the answer? Your prediction is a little bit similar with the actual value. Is there any way that you can say, my output is an almost good, almost bad? Any idea about it? Because see, I'm not telling you, I'm not giving you all the factors, all the answers to you. I want to know that your side also. You can just about think about generally how can we check when the 20% of value have a big gap. Yeah, now the point is that, see, the way you said no, that 20%, when I pass the 20% of test size, then I get the big gap. If I pass the 30% of data, that time I got an difference, means 75 to your actual prediction is at 75,000 and your prediction value is in getting 74,000. See, that is a similar, no, that is a little bit nearest value. That time you can say my model is giving particular answer isn't correct. Why? Because your regression is data. You are not working on the binary classification or multi-classification. You are working on the regression. The regression will not give the actual answer. Your prediction value is in 85,000 and your actual value is in 85,000. It's not possible from the regression. You cannot expect the same answer from the model. Is it correct what I'm telling to you? Here we are trying to predict 20% value with the value of 80%. Yeah, you are predicting, yes. But see, teaching is important, means training to your model is important. And gap is big. Gap. Your question, and the way I'm getting the question. You are thinking about on the basis of training and testing set, or you are thinking about we are passing 80-20, that's why we are getting gap between the y value and prediction value. That's the thing, that y value and prediction value, the gap we are getting that because of 80-20, that's the correct thing. If suppose if I pass the 90-10, if I pass the 90-10, definitely what will happen? The possibility is that some kind of your gap will reduce or gap will increase. If suppose gap is reducing, then model is giving good output to I will tell you that wait one thing. One is the year of experience of the then sir I will tell you the positive and negative things. I will tell you, just give me a second. Is the year of experience of the data and the prediction data same? If not, predicted salary will be the different obviously. Year of experience, the data, prediction data same. Not predicted salary will different obviously. Actually, year of experience of the data, the test data, and the predicted data is the same. Means the way you are saying that actual data and predicted data is the same. See, it's I think this is in the regression. Very rarely you are getting the same answer. Are you getting a point? Very rarely you are getting the same answers. Why? Because just imagine now in this data set we are having only 30 data points. What is the probability that you are getting in the client in when you get the client that time you what is the probability that you are getting only 30? Why not a 30,000? Why not you get in 3 lakhs? Is it correct? No. So definitely your model is going to learn huge amount of data, huge amount of, and that will impact your data is impactful. If suppose if you want to reduce a gap, why not you go for the checking your data set? Check out one thing now we are going to discuss about. Salary could be on their position in the company. Now, check out. Performance matrix that we are going to learn in a different session. Okay, we'll take a one different session on the performance matrix. First, we will include all the possibilities. See the steps. What is the second step? Third step. Or you can say model prediction and performance matters. See, now the question is that what type of questions you will get into this means current scenario. See, I'm not explaining you about uh, the deeper into the linear regression or deeper into the multiple linear regression. I haven't gone through that one still. Okay, but what I want to teach you that the steps and what kind of questions you will get, because when I started the working in the this whole process, no, that time we are not going to learn about definitions. Okay, so I'm telling you the what are the definitions that is important for us, and even stages also, and even I will take another one example as well. Okay, so first I will tell you the possibilities that what kind of questions you will get here. Can I tell you now? Yes. Independent, independent and dependent variables. Implementation. My spell is correct. Implementation. MEM. Sometimes my spell is not going good. Are we trying to find out the best fit or the most fit here with the sample data? We are actually, that is depends upon your testing sizes. The way we are best fit means the way you asked, in the previously question, means how did you find out? How did you say, you said no? How can you believe on that model is incorrect? So that model is nothing but your best fit, means best fit line. You are implementing the best fit line. Even we never discussed about the slice, slope, intersect, hypothesis. Means that is hypothesis is nothing but your best fit line. Yes, sir. Are you getting my point? Actually, when why this kind of means terms are coming, if I started directly into the implementation, means every algorithm, you will get a headache. What is going on here? So before that, I'm telling you and teaching you all this process, all the processes, all the structural point. Means if we enter into this model prediction, what we have to do. That's why I'm telling you. Okay. So do not worry about this. Why this is whole process is going on. What are the steps of ML algorithm implementation? And another one question that we are going to what is linear regression? What is why to divide your data into training? This is a major question. Train and test set. What is the so many of the terms are there. Still, I haven't passed, but these are the terms that we have. Means we have to learn about this. You will get in this kind of questions as well. Implementation, machine learning, and data science. You can some of the questions also I'm passing. You have to learn about what is science, what is mining. These are the general terms, okay? Scientist. Is it correct, myself? Right. So these are the terms important. That's it. So whenever you want to go for the interview process, no, that time you should go for this part of structure, because definitely you will get this kind of question. Data science, what is data science, machine learning, data mining, data engineer, data scientist, and what is the difference between business analyst and that data analyst? What is the work difference in business and data analyst? See, business analyst is in both based on the process of your domains modules, because there we have the some the ERP system or enterprise resource planning, right? So business analyst is in completely work that comes under the out of the box, means means managing the businesses. There we have those domains. Actually, these people, those are in the business analyst. No, these people comes into the different domains. ERP system has there are near about 12 major modules like IT department, HR department. There we have the associate consultant as well. The positions associate consultant. What is the work of them? These are the same that they business analyst. Are you getting my point? And data analyst is in pure work. Means purely this position is dedicated with the IT department. Means IT departments you are completely work on the data only. Business analyst will do only what? Only suppose the domain based work. Domain based. Dedicated domain based work. Client handlings and all and all. Right. So I think till now we don't have an I think question. Let's go for the another one implementation, and then I will go for some. You know what? Actually, nowadays, now you will get in so many questions, but the all the explanation. You know, many of the client interview sessions, they will put directly coding part, and they say implement the algorithm. So what can you do? What can you do? You have to know about some coding structure related work, right? House price. So I will take this target price into the Y data, and others are into the X. So it depends upon you that how much data you can take into the X data. So is it possible? Is it correct? Is it necessary to go for the all the data, all the means we can pass the Y data in dependent variable. We can take as this one. And is it necessary to go for the all the data, remaining all the data into the X? What do you think? The 12th column is in column, so I will take till resale. So this is in 12th, suppose 12 columns, 12, 11, 10, 9. See, address also comes, so I will remove this address column. Yes, we got it till the resale. Okay, and if suppose if I print Y, check out we got it Y. So now what is the work of second work that we have to do? How much data we have? Total data set 29,000. Okay, almost 29,000. And you know what actually? One thing that we have missed. One thing that we have missed. You cannot pass string data posted by NDHR. What we have to do? What we have to do? So what is the code for label encoding? Can anybody? What is the code for label encoding? I told you before. You have to tell me now. Label encoding. What is the code for label encoding? Can you pass label encoding? Label encoding is different, no? Label encoding is different. It's pre-processing, yes. It's pre-processing. So what we have to do here, L1 is equals to what? Sorry, actually encoder I have to pass it. What I have to do here, L1 dot fit underscore transform. Is it correct? Fit underscore transform data set POS, sorry, POSTE posted by. For the BHKRK as well. We got it. Okay, this one data and this one data. Then we go for a slicing. Then we go and Y, and we can go for X as well. We sorted down our problem, and then we should go for random state. I'll pass here 2, so 80/20 I will do here. Training set and testing set, model prediction, execution, that we got it here. What is the next step that we have done here? That is prediction. So let's check out the shape as well. So you will get to know about shape size. Okay. See, almost 23,000, 560 and 80, 58,000, 5,891. Okay, that's the major point now. And let's implement this linear model on. See, you can use the same linear model independent way, means simple linear regression as well as into the multiple linear regression process. Okay, so when I execute this one, see, executed, and what is the I'll use ypred is equals to r1 dot predict into the bracket. What you have to pass? X test. See, you can pass the one line as well, means single data points, but we have to create whole array. See, this is what is the shape of this one? How much answers we should have to get? The size of X test, no, that much your ypred size. Is it correct? 5,891. And your how much questions you have asked? 5,891 questions you asked. How much answers we got? 5,891. Are you getting a point? See, the comparison is important. I know that. Actually, comparison is important. So what we have to do, the question that much. Okay. See, I'm just sliced down the one line of that code. Okay, the every columns data we have here. And what I'm going to do here, I'll remove the X-test and pass it down the array. Okay, and after the array, I'll pass here. So check out, I'll do like this one. I'm asking single question, single data point, single transaction like this one. Okay, so so we should have to check. See what I'm saying? We should have to check the first data points target value. So target value is in my first data point is, see here. So this is no, this is my first data point. The target value, target price of that first 55 lakh 0. So if I execute this one, we should have to get the nearby value of 55. Okay. So I'm just making the execution here. I think we got an error. Expected okay 2D array. So if you should have to pass here like a double square brackets. Okay, not an issue. So I'll execute this one. See 51,050 rupees something means, sorry, 51 point something means 51 lakh, and your actual value is saying that how much salary, sorry, not in salary, how much target price is there, 55. So let's go to little bit comparison purpose. I'm just passing here 55 lakh and your model is predicting 51 lakh. Now, see, you guys are thinking about how can we predict, how can we believe on our model that he is giving us a 51. See, already I have said you can, if you changed your testing size and if he changes the output, and check out the output as well. If you are increasing the data points or decreasing the data points. If you are decreasing the data points, your value is increasing, or if you are increasing the data points, your value is decreasing, means your output value is decreasing. It depends upon you know the way of believing it. See, in this scenario also I can believe that because you are my value is in some kind of 4,000 4 lakhs of difference that we are getting, 3.5 difference we are getting almost. Is it correct? No. So 55, I already my training value, my actual value is saying that 55 is enough, but my prediction value says 51.5. So if suppose I am satisfied with this one, that I say my model is best, but depends upon us that how can we believe on it, because somewhat model is giving answer. No, that's good. No, you else you can go for here, you can change it here. 30 you can make it. Once again, you can go for that. Once again, go for the prediction. Check out 55, 51.53. Even your model is giving correct one, means same answer. If you go for one, check out 51.85, 82. See, your accuracy means your values is not changing, means 51.8, 51.2, something kind of you are getting value, but you are not getting a change, a big change in means prediction to three values. If you are getting three prediction values, they are giving us a similar kind of structure. Are you getting a point what I'm trying to explain you? Actually, you guys are thinking about a lot of work is here we have, right? Lot of, you have to think a lot of things. My voice is audible to you guys. 100 rows for the test and the rest of values as a training data is, that can make it more accurate. See, that's why I'm telling you, you cannot go for a, see, you if you want to go for that, it's okay, not an issue. But what is the possibilities? What is the probability if you pass the 99,000, means about out of 1 lakh? What is the probability that your answer will get accurate? Now you will ask me, what is the factors that affecting on the output accuracy? See, the first thing, your size of data set. Second thing, see the columns. See the columns. Your square feet column is saying 1300, 1275, 1933 to 9029, and others. The check out the other columns as well. They are some kind of around 2100200. Can I ask you one question to you all? In the linear regression or in the model prediction in the machine learning, the relationship between the two columns or relationship between all the columns are matters or not? Is it possible? No. The relationship between the columns are matters? No. Now tell me, if suppose these are the small kids and this is the only one kid isn't big, this is matters. So this is the major impact of the square feet column on the that prediction value. That is square feet there we have, because others, check out the other small kids are there and the square feet isn't single one big kid is there. So whenever you go for the prediction, no, check out the square feet column. How can we reduce that strength to lower level? How can we reduce that square feet column strength to the lower level? Why? Because you should maintain the balance in the data set. Then you can believe your accuracy is going in the good direction. Am I correct? I think you guys are thinking about what is the new thing now why I got there, right? Means the way I said, no, the data points are matters here. See, can we use the linear regression using only the square feet? You can slice down. You can pass any question. You can pass any column. You can ask the question on the basis of under construction also. See, whatever the ethical things are, means dedicated with the finding the price, no, you can take that data. If suppose finding the price of house is not necessary, suppose if RERA is not necessary with you, your client is saying take this data but do not use RERA because my flats are not RERA approved, so remove that RERA column. That time what you do, you can remove that RERA column and pass it down all the data into that. Are you getting my point? It depends upon your problem statement. If your problem statement is saying square feet is not good for, don't take a square feet because I am not selling my flats on the basis of square feet. That then what you do, you can remove the square feet column and then go for the prediction. Are you getting my point, everyone? I think today's discussion is also most important discussion. I think, see, stay means do not think about other thing, other parts and all. All the problem statements, those are we are having here. All the points are depends on the your problem statement. If suppose your problem statement is strong, then everything is strong. Your problem statement thinking about some sort of data set, then you can go for some sort of data set only. Do not think about we are going into the every time we are getting exact answer. Exact answer you do not expect from the machine learning. You cannot say your answer is getting here one and one only. Some if you go for the suppose binary classification, multi-classification, there you can get, but in the regression you cannot expect. Okay, and if suppose your interviewer is asking to you, is it possible the exact answer means whatever the exact answer we are getting, is it possible that we can get exact answer in regression? If you say yes, then definitely you will get a problem. You can say that the probability means possibilities only. You can predict possibilities, but it's not necessary that 100% you are getting the same answer. In the predict one, yes, I'm telling you about predict. If you go for the classification algorithm, then definitely that you can decide that there should be a getting same answer the way already we have, right? But machine learning whole process is not an trustful process. Machine learning always into the 50-50 chances. I think that's all from my side today, because even we have discussed and implemented work, right? And even I will share some theoretical work as well through the portal tomorrow. And you can go for the execution working with the definitions, implementation of this one. And when we come up into the, when we come up in next session, no, that time we are going to work on some theory part of linear regression to understand, and some theory part of logistic regression to understand. And definitely you will enjoy coming sessions as well, right? So guys, I think let's go for the next session in the next week. Until then, take care of you all. See you. Bye bye. Thank you. Yes, I will share some, no problem.